Okay, we've been spending a lot of time and energy working on how to factor polynomials from a variety of perspectives. Now I'm going to show you why that's such a good skill to have. In this situation, notice we have an equals sign. Okay? And that equals sign means we have an equation, and there's a number or many numbers we can plug in for this variable that make this a true statement. We want to figure out what those unknown number or numbers could be. Now, factoring is a great way to approach this. Now, as I've said before, not everything factors, but it's the easiest way to try and the quickest way to solve something if factoring is an option. So let's see how we would do this. One of the goals we worked on earlier in the year is to take something that looks complicated and always try to move every term over to one side and make this whole thing equal 0. That way it might be easier for us to recognize and approach. So what I'm going to do is I'm going to subtract 30x and subtract it over here. Now remember, I can't combine it with any of those other terms because they have different exponents. So I'm just going to rewrite this now. I've got 2x cubed minus 4x squared minus 30x equals 0. And now I got this trinomial on the left. There's 3 terms there. What I need to do is think about all the tools I have to factor and see, is there a way I could break this up into a whole bunch of smaller pieces that are all multiplied instead of having all these separate terms that just don't go together? Now the first thing I'd probably recognize is that they all have something in common. Okay, what is that greatest common factor? I think I could take each term and divide it by 2x, because I notice that everything has at least one x in it and everything can be divided by 2. So I'm going to do that. I'm going to divide everything by 2x. Now it's important to remember, we're not trying to change what this means. We just want to change the way it looks. So that 2x can't just disappear. I'm going to write that right here and make sure that it's still part of my problem. But what I want to do now is see what's left over. Okay, so if I were to divide everything by 2x, this first term would become x squared. The second term would become negative 2x, and the third term would become negative 15, no x, because x divided by x gives me 1. Okay, now it's starting to look a little better. It's taking shape. I got this 2x out front. Just leave it alone, kind of pretend it's not there for right now. Now let's take a look at just this stuff right here. Okay, this big trinomial can still be broken down, and we've referred to this before as the backwards FOIL method, being able to factor it into 2 binomials, 2 different things, each with 2 terms. Now without getting too complicated, let's just think about this. X squared comes from x times x. And what are my options for 15? Negative 15. Well, I could have 3 times 5 or negative 3 times positive 5. So one of them has to be negative. I could also have negative 15 times 1. So just think about what different possibilities there are, and those possibilities you have to choose from have got to add up to negative 2. So if I had x plus 3 and x minus 5, that would be the correct way to factor it. Now if that's something you don't recognize, we need to go back and study up from first semester on how to factor basic trinomials. This is one of those skills we need a lot. It just shows up frequently. And don't forget, I still have this 2x out front. Now what we have here is much easier to deal with than what we had at the beginning. But all we've done is write it a different way. We have not changed anything. This is still equal to 0. If you're able to get to this point, you can solve this equation without much math at all. You can do most of the time you can do it in your head. Look at this group right here and say, what number can I plug in for x that makes that stuff right here equal 0? And the answer to that is 5. 5 minus 5 is 0. I can take this over here and say, what makes that stuff equal 0? And that would be negative 3. And then I can look at this stuff and say, what can I plug in for x that would make that equal 0? And that would have to be 0. 2 times 0 is 0. Now what I've done here is all I've had happen really is I picked a number that would make one of these groups, for example, this one right here, equal 0. It wouldn't make this group over here 0, but it doesn't have to. As long as 0 is somewhere in that product, the whole answer is 0. So I've basically found that this trinomial had 3 different solutions. My solutions are x equals 0, 5, and negative 3. And it doesn't really matter which order you write those in. And as a last side note here, I'll show you what those really represent. Eventually, when we get into graphing these things, you're going to notice that this looks something like this. It's kind of a weird little graph that you aren't necessarily familiar with at this point. Okay? But if I were to draw this on an XY axis, I would find that the following is true. Look to see where it crosses my x-axis. Right here, and right here. And guess what the locations of those are? Those are my solutions. 0, 5, and negative 3. Those are my x-coordinates. So I found those solutions that are also called roots, and I found them by factoring.